Okie dokie. Huh? It's a while ago.
Yes.
Alright. It's before or after types? After, probably. Odd or even. Compose. Inverse. This one?
One question.
Which one?
Couple.
Yeah, pick. F. Okay, let's start with F. One at a time. Right, so we have fx equals e to the 13x minus 7. That is 1f. Let me just make sure I have the answer right. I do. Okay. So, for something to be invertible, it has to be at least 1-to-1. If it's 1-to-1, we have a chance of it being invertible. So we have a quick check if it's 1-to-1. There's a couple of ways to check. One way to check that it's 1-to-1 is if on the graph, when you draw horizontal lines, it only intersects once, and if you draw vertical lines, it only intersects once.
Yeah, this one is obvious.
Obvious, so the answer is yes.
No, but I mean the onto.
Onto?
There is two conditions to be invertible.
Yeah.
On
and onto.
Yeah, I want to know.
Onto means that the range is equal to the real numbers. Again, it's from the graph. So this can only be positive. Can it be negative? It can't. E can never be negative. Remember in semester 1, when you study the E graph, it's always positive. Yeah. Now, if you look at my answer though, for 1f, you see that I say, yes, it is invertible. But you might say, well, how is it invertible? Because it's not onto. But there's a trick. You can make it onto. All you need to do is change the codomain. So you say that f is all the real numbers to the positive numbers. So now your function goes from OR to the positives, not including 0. So now it is onto because everything gets covered here. So really, you only care about making sure it's 1-to-1. That's the most important condition. And the easiest way often is from the graph. So if you picture the graph, this one, invertible or not? Yeah, let's see if we can do these in our head. So A, yes. B, no. C, no. D, yes. E, I believe no. But I'm not certain. So we might have to check that one. F, yes. G, not certain. H, not certain. I, yes.
How did you know it? You looked at inside the link.
It's helpful. If you have a log and a linear, yeah. But this one, a square root and a square, don't know. So a couple of these aren't clear. We'll have to examine them more closely.
Okay, how about the cos?
Cos is definitely not, because cos goes like this.
And the tan is yes.
The tan is also no, because the tan goes like this. It fails.
What is that?
It fails. Yeah. So most of these you can tell, but some of them you have to examine more. And we can do some examples next time if you want. The graph is the nicest way, but another way to check you can try and find a turning point. Do you remember turning point? No turning point?
Yeah.
So, yeah. If it has a turning point, like a minimum, then it's definitely not one-to-one, because you can draw a line here that has 2. So you could see if there's any turning points. If there's no turning points, then it's probably one-to-one. But if it has a turning point, then it's not.
What if it has a turning point?
Like what? Describe the shape. Do I go up, down, left, right? What do I do? No. I'm going to move my pen. You tell me which way to move it. No, use words. Up, down, left, right.
Because it's a curve.
Look. Say up, down, left, right.
Okay, you're right.
No, yours. Don't worry.
Down and left, up and left.
Down and left?
It's a curve.
You don't want it like a line. You want
Like
it
this?
a curve.
Yeah.
What letter is this? C.
I want it that.
You could have just said C. Right. This is not one-to-one, because although it only crosses horizontally once, it'll be vertically twice. So it's one too many.
But does it have a turning point?
It's kind of weird. I suppose technically no, it doesn't have a turning point, because the turning point needs to be on the X, not on the Y. Yeah. Okay.
Yeah.
We'll finish there.
Yeah.
Okay.